Okay, so the purpose of today's lecture is to start a set of 3 lectures by 3 very kind students who know more about implementing the stuff on the systems you may be used to than I do. This is a class that easily falls in applied mathematics. It's co-listed with statistics. When you have a class like this on your transcript, people will assume a certain basic proficiency. And one thing is we've talked about the theory of doing linear programming, but at the end of the day, you actually want to be able to use it. For the most part, it doesn't really matter what system you're using unless you're doing a problem of such complexity that you really need to exploit the most efficient possible. So what I want to do today and in the next few days is talk a little bit about some systems you can install on your computer to run some very simple linear programming problems. You can also do Microsoft Excel. I will post some links to some videos on how to do all of this with Microsoft Excel. This is being recorded, so I have to be very careful as to what I say about Microsoft Excel. I will say that it is very much in use by a lot of places in industry. Being able to do something like this in Microsoft Excel means that what you're doing will be exportable very easily to other people's systems. Mathematica, for the most part, is not being used by the financial firms. MATLAB may be a bit more. R is freely available. So in terms of what are you using, you want to have a system where you can show and share it with other people very easily. And so what we're going to do is we're going to see a little bit about how you can install some of the stuff. We'll be sending you instructions so that before Wednesday's class you can try to install. I know not everybody might have a system or a laptop where this is going to work. If you don't, find someone else in the class. I want to make sure that everybody can write and run a very simple linear programming problem. All right, I'm going to turn it over to you now.
If you guys want to get your laptops out and follow along, if you have R installed already, feel free to do that.
Let's put this
in
between.
All right, should I start? Okay. So the 2 different programming languages we're going to talk about, at least for today, are going to be R and Python. R is a statistical computing language. It's a scripting language, meaning it runs one line at a time. You can sort of type one line, run it, type your next line, run it. It's used in very specific settings of like stats and math and big scientific computing. We're also going to talk about Python, which is a more general purpose language. It has very good support for scientific computing like R, but is also useful in a wider range of things. A ton of different kinds of software is written in Python. I mean, like Reddit is written in Python. Other things are Sublime Text, this text editor we're going to use is written in Python. It's just, you can do about anything with it.
It's really fast.
Faster than R.
Faster than as a general rule, the lower you program in, the faster it's going to be, but the harder it's going to be. Mathematica is very easy to program in. It has very good interfaces, but it's very slow.
Yeah. So the first important thing to know for any kind of programming is how to use a terminal. All right, is anyone comfortable using it, or do people use terminal usually? Do you know like basic commands to move around? Okay, I'll talk through that. So this is a terminal. It's a way of navigating the file system and running programs. And you see in blue it says this documents, that's the directory we're in. Your terminal might not have that. You can customize what your prompt looks like, but that's listing the directory we're in. So to move around directories, you use CD. So CD stands for change directory. Actually, first I should say, if you're confused about where you are, PWD, print working directory, will tell you the name of the directory here. So right now I'm in users/Benno documents, Math317 lecture. And to move around, you use CD. So if I want to go to my home directory, that's tilde. And so you can do tilde/ and I can hop into downloads or something. And now I'm in downloads, and any commands I run will be run relative to downloads. So I'm going to pop back over to the one that I actually want to be in. If you're in a directory and want to see what the files there are, you run ls. ls is going to list all the files in your current directory. So in this directory I have, let's see, 2 CSV files and a Python script. So the basic ways we're going to interact with these 2 programming languages, you can either use what's called a REPL, a read eval print loop, where you enter one line, it runs it, prompts you to enter another line. It's very interactive. Or you can write a whole program and then run the whole program. So I'll start with, oh yeah, if you want to go up one directory, cd ... will take you up one directory, and you can do that relatively. So if I want to go up 2, I can do like cd ... /... and hop into some directory for some other class.
It's like if you click the wrong file, you moved in the wrong direction. You just move backwards.
Yeah. So R and Python both have support for read-eval print loop, which is actually not universal in programming languages. And you can also write a whole script and run the whole script, which is useful if you have something bigger, more substantial that you don't want to just be running line at a time. Also, if you want to save it to run it repeatedly in the future. So if you have, okay, so you need a terminal. You'll need a text editor. Over here I have Sublime open. It's a pretty simple one, pretty standard. A lot of people use it. I would suggest you get that if you don't have a preference already in text editor.
We'll give you directions on how to install that.
Yeah, so if you want an R REPL, very easy, type R if you have R installed. And then you can run code here, and it'll evaluate it and tell you the result. So it's going to print hello world, or I could do 1 plus 2. It'll tell me the result. You can do stuff like that. You can also do more complicated things, obviously.
You can print goodbye world.
Yeah. And then to close in R, do you do quit? Does that close in R? How I usually close R, Control D will send an end of file character, which closes it. I don't want to save, so I'll press N, enter. For Python, you can just type Python. You'll get into a loop like this. And similarly, you can do 5 plus 3, or
Wow.
or you can do lots more complicated things. Yeah, obviously. Python, this is a kind of weak REPL for Python, but there are more complicated ones. BPython is a very popular alternative to that, that some of you guys might have installed on your computer already, that has some automatic completion. So like I can say import os dot, and it'll tell you these possible completions. And this just gives you operating systems utilities, but you can import all sorts of different things. We could import, I don't know, sys, and then call things on sys. So a REPL like this is pretty useful in that it tells you the exact things that you might want to choose from, and you don't have to guess at it or look it up or anything. And again, Control D to quit out of that. So that's useful if you want to sort of test. It's a nice sandbox to figure out how things work, play around. But if you're doing anything substantial, you're probably going to want to write it in a file and then run that file. So for R, how you do that is open it in your text editor. SUBL is my just shortcut to open a file in Sublime.
Okay,
so,
is that your editor? Or
yeah, that's this editor over here.
Then I think RStudio is probably.
I don't have RStudio. I just use this.
Okay. RStudio is another way you can.
And that's all one thing packaged together. You can also use Emacs if you're comfortable in Emacs, or Notepad++ is a popular one, I think, on Macs as well. I don't know any Windows ones, but some editor, you can open a file. It's common to use a .r file extension for R scripts, and that'll open it. And then you can write some code in here. So we're going to say print hello world. And then I'm going to save that. And then if I come back over here, you can run R files using R script. So R brings you into the REPL. R script will run a script. And you just tell it the name of the script you want to run. And that's relative to your current directory. So if script.r is not in your current directory, that'll say, I can't find a file script.r.
just to make a brief comment, think of this as if you haven't programmed before, think of this as very similar to tech. When you'll write a tech file, you'll save it as .tex. You want really good file names. And you can write a tech file in anything you want. You can write it in Notepad. You then need something that will take the tech commands, process it, and generate the file. It's the same thing here. We're writing a code in some kind of editor. We're not running it line by line. We're writing some code, and then we're going back, and then we're evaluating that code in another program.
Yeah. So this is just like calling PDF tech on your tech file to turn it into a PDF, except we're calling R script on our R file to run the commands inside. Similarly for Python, we would just make some Python script. So that opens that in my text editor, and then we could say print hello world. And then to run that, you'd actually just call it Python. There's no separate command to run things versus open the REPL. Python script.py, that will run our Python file. And I told it to print hello world, so that's what it will do.
Quick question for people who are paying attention. Is it the same command in Python as it is in R? What's the difference? Right. This is one of the worst things possible in programming is that different environments have slightly different commands, and you have to remember where you are.
And this syntax here, where I just say print space hello world, Python supports two ways of calling functions. You can, or I think Python supports two ways of calling functions. Most languages like it do. You can either just put a space and then the argument, or you can put it in parens and it would still work. So Python's pretty flexible in terms of syntax. There's a lot of different ways to write code. There are idiomatic ways to write code and bad ways to write code that'll both work. R is much more rigid. Basically, if it runs, it's probably right. Python is more subjective. So yeah, that's sort of the basic workflow that we would advocate for doing things in this class.
A little bit of advice. So, who's going to be learning this on Windows? You should probably find a friend with a Mac. I'm a PC guy, and it is really just not good. It's
There's a good IDE for Python on Windows.
Yeah, but
It works pretty well.
the whole thing. I can send directions, but like it's a little easier on Mac, especially if you're
And
learning.
if you can send us what you're using on Windows for Python.
Yeah.
But we're going to go over Python, and if there's interest, I'll do Mathematica.
Yeah.
Okay. You guys want to start talking
Yeah.
about R?
Okay. So let's. So the point of today is to actually teach you guys how to do your programming process. I'm just gonna write one out on the board, and it's gonna be nothing new, but then we're gonna translate it to some code.
So if you're going to write, I'm going to give you the...
So we're gonna do a diet problem. Okay. We've all seen
Your
this
tie?
before.
The tie, sir?
Oh, right. In this diet problem, we're going to have 4 variables. This is a nice chalkboard. I wish I had this for my colloquium. Is this why you get this room?
No, I get this one because no one else wants it.
That's pretty true.
Yeah, piss someone off.
Does anyone have any questions for Benno about any of what he just covered while I'm writing this down?
What is your like sublime shortcut? How do you actually get that out? I'll send it out to you guys. I alias so when you type a command, your shell has a list of places that it looks in order. You're just gone. So that's why we can refer to these. So when I say subl or Python or R script, there is a program somewhere, obviously, on my computer that's running, and it looks through your path to find that. And that's why Python doesn't have to be in this directory to run. So I put the little script that I wrote in user/bin, which is the first place in path by default, and that opens Sublime. I'll send out the link and tell you, or yeah, I can include that and some other configuration stuff. Because this is a pretty, like you saw my terminal up there, it has some kind of different colors and stuff going on and more stuff in the prompt than, like if you just open terminal by default, it'll be white with black text, and the only prompt it'll show you is a $sign. And that's kind of hard to use, I find. So I can send out my terminal configuration stuff if people want. What? I don't know.
If I know it's brown.
Doesn't sound right on brownies.
You guys just gonna complain the whole time?
That's colas, right? Actually.
Colas, yeah. But this is not a healthy diet.
So I'm just copying. Like I'm not really thinking about him.
This is the secret Nordic
At least
skier
Mary
diet.
does read a lot.
Whatever.
Okay. Alright, so that's just a simple diet problem. We just kind of chose random numbers. Yeah. So, for those of you who never worked with R before, so we'll give you instructions on how to install R. And our preferred IDE of sorts is RStudio, just because it's like the teacher and step
Yeah.
one.
It sort of
And-
wraps together the things I showed, which is a terminal from which you run it and an editor in which you edit. This is just a program that is an editor with a button that you press to run it, which can make things easier.
And this
Same
will work
difference.
just fine on PC. It's really just a Python. It's a little harder.
Yeah.
It's called RGUI on PC, and it looks pretty similar to this. So,
And GUI is graphical user interface.
I think so. Yeah.
Make it not RStudio on PC.
Maybe I just might be running.
I'm sure there's more than one IE for R.
Okay, so these are constraints. We've seen constraints before like this. This is nothing. We're not going to really talk about like, why we chose this to be the way. Like that's not really the point of today. We're just going to show you if you have something like this, how would you solve it? So we also need an objective function. Which I will put, I guess, can you guys see if I put it here? Okay.
So this first one, I think you can just do correctly instead of doing the other ones you just have to go for it. Yeah, okay. So that problem is pretty much up. Okay. So for R, turns out when you do linear programming, there's this package called LPsolve that makes everything really convenient. This is what it looks like. Here you have, so it makes like an LP object, and then and then you put in some arguments over here, and then it goes through. I think it's based off simplex method and branch and bound. I'm not sure, but then it actually goes through all those algorithms for you and solves your problem for you. And all you have to do is just enter in the arguments where you see fit. So for direction here, you know, are you trying to? Is this a minimization problem or a maximization problem? Objective, constraint matrix, constraint direction. Here's a matrix of like greater than equal to, less than or equal to, etc. So this is kind of what it looks like, but yeah. So the first thing we're going to do now is we'll slowly program that out in R. And just show you guys how it's done. Yeah. We know that comp size is not a prereq for this, so. Yeah, and for those of you who know R, like, sorry, this is really painful. Yeah. Okay.
But okay. Oh, you got it?
Oh, wait, do you want it? Okay.
Okay, so we're gonna call our. Can I turn this brightness up?
Yeah.
Are you gonna run out of battery?
It's not installed. Should we first install it?
Yeah, I am. Okay, so for the first thing you want is you want to install this package, right? You want to go, and it's really simple in R. You just install.packages. Oh my gosh, everything's just not like my computer. And it's called LPsolve. The S is capitalized.
And for those of you familiar with other languages but not R, R is weird in that dot doesn't mean call a function or access a variable. Dot is just a character like any other. So that you're calling a function whose name is install.packages. You're not calling a function called packages on some object install.
So when you install a package like this, given that you're on your same computer, you only ever do it once. But this is to get a package that does not come with R. Most things come with R, but this doesn't. But when you do library LPsolve, you have to do this every time you open your window again. This just calls up the package. So now we're free to use anything, to use this LP package.
Can you put that line of code in your linear programming problem directly? Can you put in your R code something that calls the library LPsolve?
Yeah.
Yeah, you would put that at the top of your file.
Okay.
Yeah.
Very important.
So yeah, I guess I should. How do I run a script on?
You don't need to run it. It just does it by itself.
No, but new scripts.
Why?
can I type here?
No, you just type here.
No, for this though.
Yeah, you just type here.
Okay.
Yeah.
Oh,
Hold on, can I?
yeah, sure.
Okay. So, yeah, you can just type here.
See, that's not just me. Okay, there we go.
What are you trying to do?
Yeah, I was just trying to make this bigger.
Move the bar.
Yeah. Okay. So the first thing we're going to do is we're going to start with our objective function. And this little arrow here names like an object and variable, etc.
Wait, you did it the wrong way.
Did I? Oh, sorry.
Yeah. And we're calling it f.obg just arbitrarily. It's just a nice way to call that.
Yeah.
You could call it cat.
Yeah. So for this, your C.
You have a question?
Yeah. What's up?
How is it different from an equal sign, the arrow?
It's not. It's an assignment operator.
Yeah.
But it's assigning what's on the right-hand side to the name on the left.
Yeah.
Yeah.
It works the same way as equals does in
Not
other
the exact same thing.
Yeah, let's just use equal sign.
This is
Okay.
just a convention to say, but okay. Yeah.
We're
and-
get into good habits.
Yeah.
And the C here, it means concatenate. And in this particular case, it's making a vector, but it doesn't have to be like a vector. C is just concatenate. And as you can see, these are the coefficients that corresponded to the objective.
So we have 50, 20, 30, 80. Literally just 50, 20, 30, 80. So makes a whole lot of sense.
But the C has nothing to do with the fact that in canonical linear programming problem, we write it as C transpose X. C is something completely different.
Just how you declare a list. Same as square brackets in family languages.
So if our objective function was 40x1 unit change, it's really that simple. Now what she's doing right now is she's going by row and just putting all of this stuff. And you see we have, I should have a cabbage shot.
So declaring matrices in R is weird. Some of you might be used to declaring matrices as sort of lists of lists, like two-dimensional lists in most object-oriented languages. In R, you just give it a long list of values and tell it how many go in each row.
Yeah.
So to make like a 4x4 matrix, you give it 16 values just in a flat list and tell it I want 4 to a row.
Yeah.
You just go on row 1, 400, 200, 150, 500, row 2, 300, 200, 0, 0, but it's all in the same.
Yeah.
And you don't have to tell it how many columns because it will figure that out because it knows how many rows and how many entries there are.
Yeah, notice
Yeah.
she said number of rows equals 4.
Yeah. And
Is
by
it zero fill if you don't give it enough?
I think so. Yeah. And by row, here it says like by row equals true. That just means like do it by rows. You can also do like by columns actually, but by row is just like how it's more commonly done, like by default.
Yeah, yeah.
Yep.
So your matrix command has like 3 parts, but you have to like put in the actual values, then you put an n row, and then by row.
Yeah.
Oh, can you scroll
yeah.
over? There's a comma here too.
Oh,
Yeah.
You see how this? Do you see how these parentheses
Yeah.
close off, and then there's a comma probably.
after
right
the
here.
close parentheses.
It's this window's just slightly too small.
There's probably more optional arguments you can give
But
it.
those are the 3 you have to.
And I would bet that by row is also optional and there's some default value. But you need to give it at least your list of values and how many go in a
Okay.
row.
We're gonna do this really econ-y. This is how you do it.
Yep.
Yep.
Just go online, right?
Okay.
Sure.
Just like this track.
And then and then for the constraints, the signs, I think all of them are greater than or equal to, right?
Corresponding right here.
Yeah, okay, great. So then what you can do is then now you're gonna make a sort of a direction matrix of just the signs as they go down. But instead of typing it out 4 times, what you can do is actually you can use this function called rep, which will replicate this 4 times just to save you time. Yep. And then the next sort of piece that you need is this thing called the right-hand side. And this is just your B. Like AX equals B, this is like just your B matrix.
Just trying to see if I can actually get it to record anywhere.
Okay.
Is there a question?
Yeah, just stop us if you have any questions.
Yeah.
Because, yeah.
So the right hand side is
Yeah.
you can see here.
And then now you're actually, you're ready to start using this LP solver object. So for the diet problem, since it's very basic, you actually really only need like the first 5 arguments over here. So what we did was we just made these like argument objects here so that you can call it when you use the object LP.
So what was the fix for?
What?
Oh, fix. Sorry, I didn't mean to do that. I just clicked on the vectors so you can see it and then fix. Don't worry about. You don't have to type it. Fix. Yeah. Okay. So.
Can we do this in the scripter and like run it out?
Yeah, I was just gonna say
Yep.
you can totally do that. That's what I was trying to do. I'm familiar with the little different versions.
Yeah.
Yeah.
Yes. So do you guys have any questions about this step, the whole making the diet model and LP, and each of these corresponds to the arguments?
We'll also send you this.
Yeah. So this is going to be your linear programming model. And then it's actually already been solved. Yep. And then this is how you, and here, like earlier he said how in other programming languages you call things using the dot. In R you can call things using a $sign. And then here you get the sort of the object value and the solution to the original diet problem, and it's in order here.
And to be clear, $sign accesses field variables of the object. You can't call functions with $. That's how you access instance variables of an object.
Yeah.
Object value and solution belong to the LP package. They belong to, in this case, that model.
Yeah. But then, okay, so we kind of did everything by brute force here, but like what if you have a huge data set like this, and you don't want to input all of that by hand? So for those of you who like are already familiar with R, you probably know how to like use this CSV file to build your matrices and such, but for those who don't know, we'll just do it for you so you can see.
Okay, but before you do this, when you have this, matrix over here, would you be also importing the names of the things, apple pie, chocolate chip cookies, and then just telling the program to ignore them?
Yeah,
or would you...
we'll take that into
Okay.
account, the name stuff.
Okay.
Yeah. So the first thing we're going to do is we're going to load this big CSV file into R. I should just... Okay. I usually just do file.choose because I'm not sure where I say things.
And what
Yeah.
file.choose does is it opens a prompt like this, lets
Like
you choose a
this.
file, and then it will return the string name of the file that you chose. So if you're writing this in a script and you don't want to have to choose the file every time, especially because that only works in this GUI, you can just explicitly tell it the string name of where the file is. So like tilde/documents/data.csv or something, you can just explicitly give it that string instead of telling it to prompt you for a file name.
It's hard to see.
What's hard to see?
You can open the window and right in the script.
Oh, I see. Okay. Sure.